Hi, in this video we'll be looking at how to take out a common factor. So sometimes you'll be asked to take out a common factor of a polynomial or of an expression of sorts. So we have an expression here. This is an easy one. This is slightly harder. Actually, it's much harder. And even though this one looks not that bad, it's slightly harder than this one because we're going to take this a step further than just taking out a common factor. All right, so now, what is a common factor? So a factor is a number that can divide into a number or an expression, a term. So here we have 20, and 20 has a bunch of factors. So side note, we'll list them over here. We have a vacuum going upstairs, that's okay. So the factors of 20 are 2, 1, 2, 3 is not a factor because it doesn't divide evenly into 20. We have 4, 5. 6 is not a factor because, again, it doesn't divide evenly into 20. 8 does not work. 9 does not work. 10 works. And then the next factor is 20. So those are the factors of 20. However, when we look at 4x, what are the factors of 4x? Well, first we have to look at the factors of 4, then we have to look at the factors of x, numbers and variables that go into this. So factors of 4 are 1, 2, and 4. And factors of x, just x. All right, so now that you understand separately what a factor is, so let's just keep those in mind as our factors, we have to ask ourselves, what is the greatest common factor between 20 and negative 4x? All right, so the greatest common factor between 20 and 4 are, well, we have 1, 2, and 4 here. We have 1, 2, and 4 here, and there's some more, but the greatest one that they have in common is the 4. So 4 is a common factor of 20 and 4. Now, we also have to look at what is the greatest common factor with the variables, so with the x's in this case, between 20 and 4x. Well, there is no x on this side. There is just one x over here. But since there's no x over here, the greatest common factor with the variables is nothing at all because there is no x over here. So at this point, we can go ahead and open up parentheses. And now we take that 4, which is our greatest common factor, and we divide each thing in our expression by that 4. So 20 divided by 4 gives us 5, and negative 4x or minus 4x divided by 4 gives us minus 1x. So that's how we factor out a greatest common factor. And so now we can do the same thing for our medium level question that we have here. But we're going to do it a little bit faster. So first we look at our numbers. So we have 24 here, we have 6 here, and we have 6 here. And we ask ourselves, what is the greatest common factor between those numbers, between 24, 6, and 6? And the answer here should be 6. That's the greatest number that goes into all of those numbers. We do the same thing for the x's. So we look at x squared here, x to the 6th here, and x to the 3rd. And you ask yourself, what is the greatest of these 3 options that can go into all of the options? So you're kind of going to work backwards on this one. Even though the greatest one is x to the 6th, x to the 6th cannot go into x squared or x to the 3rd. Well, x to the 3rd cannot go into x squared. So the greatest one that can go into the others is actually x squared. Because x squared can go into x squared can go into x to the 6th, and x squared can go into x to the 3rd. Finally, we have some y's. So we're going to look at the y's. The greatest common factor between y to the 7th, y to the 8th, and y to the 9th is going to be y to the 7th. Because y to the 7th can go into all of the others. All right, now that you have the greatest common factor taken out, now we are ready to divide everything by the greatest common factor. And so when you're doing this, when you're approaching this, you want to do the numbers with the numbers, the x's with the x's, and the y's with the y's. So if you take 24 and you divide it by 6, you get 4. All right. Y squared divided by y squared gives you 1. And so they actually cancel out. We don't have to write anything with the x's. We have y to the 7th divided by y to the 7th. It also gives you 1. So they actually cancel out. So you don't have to write the y's either for our first term. All right. So now we have plus, and now we're ready to do our second term. 6 divided by 6 gives you 1. They cancel out, so you don't have to write that. X to the 6 divided by x squared. So remember, when you divide things with exponents, you subtract our exponents. So x to the 6 divided by x squared gives you x to the 4th. Again, we subtracted the exponents. And similarly, when we have y to the 8th divided by y to the 7th, we get y to the 1. We don't have to write that exponent there. It's just y. And now we can move on to our third term. All right. So in the third expression, the third term over here, we do the numbers with the numbers. 6 divided by 6, they cancel out. X to the 3rd divided by x squared gives you x to the 1st. We don't have to write that exponent because it's just the same as x. And y to the 9th divided by y to the 7th gives us y squared. We subtracted our exponents. And now it's done. That's as simple as this one can get. We've taken out our greatest common factor and factored everything out. All right. So now the third and final one looks so much easier than the second one, but I think it's harder because you do have to know one step more after you've finished factoring out the greatest common factor. So here, we look at the numbers and we see that if you look at 3 and you look at 147, the greatest common factor between 3 and 147 is 3, because 3 can go into 3 and 3 can go into 147. So we go ahead, we write that down. And as far as r, well, there's no r over here, so there's no r in the greatest common factor. All right, so now we can divide this by 3, and when you divide this by 3, you get r to the 2nd power. And when you divide this by 3, you get 49. Now, it's actually not finished. We finished taking out the common factor, but we didn't finish factoring the expression. At this point, you should recognize that this is the difference of two perfect squares, which I'll factor quickly now. If you're not familiar with the difference of two perfect squares, you should definitely go ahead and watch that video. But quickly, just a quick review. If you have a perfect square here and a perfect square here, and you're subtracting two perfect squares, to factor it, we have always two opposite signs. And we take the square root here, we get r and r, same thing in both parentheses. Take the square root here, we get 7 and 7, both things in both parentheses. So this is not fully factored until you've actually recognized that you have the difference of two perfect squares here, and we can go one step further. All right, that's it.